In this video, now we are going to start exercise 1.13. It states that evaluate. Evaluate means we need to work out, we need to compute, and we need to simplify the answer as much as possible. 2 raised to power 4 times 2 raised to power 3. Here, we are going to apply the rule of indices, which states that whenever there is a number a with, let's suppose, exponent x, and then another number with the same base a, but it has got a separate power like y. When you need to multiply them according to the rule of index, you write the base only once and their powers are added. So this is the rule that is going to be applied here. So I can write it like this, writing the base 2 only once and then adding the exponents 4 plus 3. So that would give me 2 raised to power 7. That is its answer in the form of indices. And if we need to uh, simplify and give the answer in standard form, in numbers form, so that could be done 2 multiplied by itself 7 times. 4, 8, 16, 32, 64, and then 128. So the answer is going to be 128. This is the index form. And this is the simple number form. Okay. Now, in the same way, it's part B, this one. 3 raised to power 5 times 6th root of 64. So we can have 64. Instead of 64, I need to write it 2 raised to power something. Okay, since I know that I need to simplify, I need to think what's that number which, when multiplied by itself 6 times, may give me 64. So you can see from here 2 2s are 4, 8, 16, 32, and 64. So when you multiply 2 with itself 6 times, that is 64. So for this 64 now, I'm going to write it down 2 raised to power 6. And then its whole power is 6th root. So I can write it like this. Or else I can do it in this form as well, whole raised to power 1 by 6. Because we know that square root is having value of 1 by 2. Cube root is having value of 1 by 3. Similarly, nth root would be having value of 1 by n, and 6th root would be having value of 1 by 6. So since that was the 6th root, so its value is raised to power 1 by 6. Now I'm going to remind you of another rule of indices, that was whenever there is a number with two powers like x whole raised to power y, then both the indices get multiplied, x times y. So you see here 2 has got two powers, 6 and 1 by 6. So using this rule, we can have 6 times 1 by 6. Now since 6 and 1 by 6 are multiplicative inverses of each other, so we can get them cancelled. So the final answer is 2 raised to power 1, that is 2. So this is how it is to be done. Okay. Then it is part C. 3 raised to power. Okay. That was only, sorry, I have just uh, not consider this thing, I need to include that 3 raised to power 5 with its 2 as well. So that will give me 3 raised to power 5, which is 3 multiplied by itself 5 times. So using a calculator, you can find it out. 2 times this is 2, 4, 3. Because when you will multiply 3 with itself 5 times, what would you get? Let me show you. Since you can use the calculator, 3 threes are 9, 3 threes are 9, and 9 nines are is 81. 81 times 3. 3 ones are 3, 3 eights are 24. So this is how you get 243. So you multiply 243 by 2 to get the final answer, which is 486. That's the final answer. Okay. Now for part C. 3 raised to power 4 is the same times 256 raised to power 4. Hmm. I need to think of a number which, when multiplied with itself 4 times, may give me 256. So if you see 4 times 4 times 4 times 4, 4 fours are is 16 and 4 fours are is 16, or like you multiply another 4 with it, so that would become 64 times this 4. So 4 fours are 16, 4 6 are 24, and then what? 256. So 256 is actually 4 raised to the power 4. So I can simplify it to give me 4 raised to the power 4, which is 256, whole raised to the power 1 by 4, which is the value of this fourth root. Fourth root of that is 1 by 4. Now again, I'm going to apply that rule. So that is a raised to power xy. So 3 raised to power 4 times 4 is the same. Now there are two powers of 4 which need to be multiplied using this rule. 4 times 1 by 4. So 4 gets cancelled out. We are left with finally 3 raised to power 4 times 4 only. 3, 3, 3, 3 times 4. 9, 9 times that is 81 times 4. But since this was a plus sign, so instead of multiplying them, I need to have a plus. So sorry, that's my mistake. This should be plus. So this is 81 plus 4. Let me correct it here. This is 81 plus 4. That is 85. That's the final answer. Sorry, my mistake. This was plus here as well. Okay, with this now, we need to continue with the same pattern. If I do part D, 2 raised to the power 4 times fifth root of 7776. Now I need to see what's that number which, when multiplied with itself, may give me 7776. Since 2 raised to power 4 is actually 16. So I can have it the fifth root of something. Okay. If you see, its unit place is 6. So that might be one of the cases that that number is 6, which when multiplied with itself 5 times may give us uh, 776. So from your calculator, you can find that that number is 6. So yes, now we can simplify it. 16 times. Now 6 has got two powers. One power is 5. The other power is 1 by 5. So using this rule once again, a number having two exponents would be solved to get their indices multiplied. So that would be 6, 5 times 1 by 5. This gets cancelled out. So 16 times 6, that is 96. That's the final answer. In the same way, we need to do its part E, that is fourth root of 625. Which is that number which, when multiplied with itself 4 times, may give us 625. Since its unit place is 5, so that number could be 5. So checking your calculator, 5 raised to power 4 will give you 625. And then since we have got its fourth root, I can write it down 1 by 4. Then times 2 raised to power 6. Now, our number 5 has got two powers, so we can easily cancel them out like this. So 5 times 2 raised to power 6, that is 64. So multiplying them together, 5 times 64, that is 320. Okay, now it's part F. 8 raised to the power 4. Let me write it down as it is. Instead of writing 8 raised to the power 4, I need to think 8 raised to the power 4. We know that 8 can be written as 2 raised to the power 3, because 2 multiplied with itself, 2 twos are 4, 4 twos are 8. So 2 raised to the power 3 would be 8. Now I need to have its whole power 4 as well. Power 4 divided by 32. I need to see to have the same basis. 32 can be written as 2 raised to the power 5. Then its fifth root means raised to the power 1 by 5. And then its whole power is 3 as well. Whole power 3. So now 2 has got two powers. So both of them would get multiplied. 3 times 4. Then divided by, again 2 has got three powers now. Let me first of all simplify the inner ones. 5 times 1 by 5, and whole power would be 3. Now it's just the simplification. This 5 gets cancelled with this 5. So I'm left with 2 raised to power 12 here. divided by 2 raised to the power 3. 2 raised to the power 3 only. Because 1 times 3 is obviously 1. So now two numbers are being divided. I'm going to apply the rule of indices to be whenever a raised to power x, two numbers with the same base are to be divided. You write them down like x minus y, provided that x is greater than y. So in this case, 12 is greater than 3, obviously. Both the numbers are being divided here, having the same basis. So I can write it down like 2 raised to power 12 minus 3. So the final answer is good. 2 raised to power 9. 2 raised to power 9 means 2 multiplied with itself 9 times. So that would give you 512, 512. That's the final answer to this part. Okay, now we move to question number 2. Now it's question number 2. Uh, to start it off with, I can tell you that any number raised to power 0 is always 1. So in part A, 8 raised to power 0 is 1 times 4 raised to power 4. 4 raised to power 4 is obviously 4, 4, 4, 4. 4 fours are 16. 16 fours are is 64. And 64 fours are 4 fours are 16 and 4 ones are 24, 256. So 256 is the answer to this times 1. 1 times 256, that is 256. So that is the answer to part A. And its second version is written to be 2 raised to power 4 times 3 raised to power 4. So 2 raised to power 4 times 3 raised to power 4. There is a rule whenever two numbers are being multiplied with the same base, same power, sorry, let the power be x, for example. That power would be individually transmitted on each of the numbers being multiplied. So a raised to power x dot b raised to power x. So in this case, you see, we can apply this rule, but in the reverse sense. There are two numbers a and b with the same power. So there are two numbers 2 and 3 with the same power 4. So we can combine them with the common power. So 2 times 3 whole raised to the power 4. So now this is 2 times 3, that is 6. 6 raised to power 4. That means you need to multiply 6 with itself 4 times. So that will give me 6 times 6 times 6 times 6. 1296. This is 1296. So obviously this one is greater than 256. So we would write 2 raised to power 4 times 3 raised to power 4, which is this number, is obviously greater than the other number, which was 8 raised to power 0 times 4 raised to power 4. So you need to write these numbers in their original given form. 1296. Instead of 1296, I've used its basic form in which the number was given to. So this is how you need to compare these numbers. Now in part B, 625 raised to power 4. So I can write it down 5 raised to power 4, then its fourth root. times 3 raised to power 6. So for this, 4 and 4th root get cancelled out. 5 times 3 raised to power 6. 3 raised to power 6 is there in front of us. There, 3 threes are 9, 9 threes are 27, and then 27 threes are is 81. Okay, 3 raised to power 4. Then I need to have 6 times. 3 threes are 9. So 81 times 9 is actually 3 raised to power 6, which is 9 ones are 9 and 9 eights are 72. 729 times 5, that is 3645. Now let me simplify the other number, that is 6th root of 729. So which number is that which when multiplied with itself 6 times may give us 729? That is obviously this. We have just simplified it. So I'm going to solve it here. 729, 6th root times 4 raised to power 4. Now this will give me this 3 raised to power 6, and its 6th root is there, times 4 raised to power 4, which is 4 multiplied by itself 4 times, which is 256. So here I can cancel this 6 with this root 6. So it is 256 times 3. 3 times 256, which is 768. So now you can easily compare these numbers. Obviously, you need to give the answer for greater. Which is greater? So this one is greater than this. And by how much? So you can write down that 625 fourth root times 3 raised to power 6 is greater than the other number, that was 729 6 root times 4 raised to power 4. And how much? Obviously, for how much you need to subtract them. Subtracting 768 from this. So you can give the answer to how much? 3645 minus 768. The answer is 2877, 2877. So that's the answer to this. And for the previous question, uh, since we had this one was greater than this one, so their answer was that this amount is how much greater than this amount. The answer is 1040. You can have their equivalent numbers and get them subtracted to give you this answer. Okay. So we are done with question number 2. For these question number 1 and 2, we are done with the concepts which involve the index notation. So that's how that was question number 1 and 2.